Yeah. Hi guys. Let's do the lead code daily question. Then it is a bit slow. Might need this thing. So, it's a easy question this thing. So count negative numbers in a sorted matrix. Okay, this sentence is self-explanatory. So we just sorted in non-increasing order. So what this non-increasing means? It might be decreasing or same order. Okay. In both row and column wise, return number of negative numbers. So one of the very basic brute force is iterate on the grid and count how many this negative numbers were there. So n will be number of rows size, m will be the grid of column size. So answer will be 0. Okay. In fact, you can just you don't need these things. For auto, so element is basically e is basically the particular row and element is the particular element. So if the element is negative, then we should increment our answer and then we should just return. Mhm. So should pass, should pass. Internet is very slow. Okay, but the main problem here is it is sorted in non-increasing order. So there must be one optimization for this problem. Although it's passing because M&M size is very less, but there must be some of the optimizations for this problem because it's given sorted in non-increasing order, right? So we should just see. Let's take this as example. We should put it here. Let's check this. Okay. Let's make it better. Hmm. So this particular thing is the matrix, and what we can see is it's somehow decreasing order. We consider this to be a graph, then it's following this pattern also, like from up to down it's also decreasing, from left to right also it's decreasing. So this is sorted. So for a particular row, what we can do is we can just make use of binary search for a particular row. Okay. So what I'm thinking of is for a particular row, I should have just do binary search to get particular index. Like if particular mid, so there should be some mid, which is the first negative number, then the afterwards negative numbers were negative, the lefts are positive. Okay, so if I got this position, like, let me help you do it better. So there's numbers which are positive, then we have mid, and then we have the negative numbers. So basically this mid is also negative. So from mid till this point, these all numbers were negative. So basically how we can solve this is, if we got this point, suppose here it's this one, then this number of columns, suppose the number of columns is m, then m minus 1 minus this particular mid is the answer for how many of negative numbers were there. You can see here 0, 1, 2, 3. So 3 is the index of this. So 4 minus, so and m is 4. So 4 minus 1 minus 3. 1, 2, 3, 4. So 4 minus 1 minus 3 is basically we're getting a 0. I should, so this minus 1 is not needed. Yeah. So basically this m minus the mid is the answer for a particular row. Okay, I think so. But there is also one thing, if you can see closely, the positives are only left top side, right? Positives are only in the left top side. So what we can do is, if we can start from very beginning, we can start from very end and try going this side. That would be too complex, is it? So it's basically like, this is the matrix, and these particular positions are positive. These particular positions were negative. Okay. So if we come from like this, like if we come from this and this, if we encounter any, we will definitely encounter negative numbers. If we encounter any particular negative number here, mm, instead what we can do is, we'll go from down to top, left to right. Okay. Yeah. So this particular approach is big of n log of m. N is the rows numbers, and this is the column. Okay. Now we are trying to make it more optimal. Let's see if we can. If we try moving from down to top, because we already seen this pattern, and move from left to right, and whenever we first encounter a particular negative number, then we already sure from this, that m minus this particular index would be number of negative numbers here. After that, we can move up. Yeah, that thing we can do. Let's start doing with the optimal one. Okay. So n would be grids dot size. M would be grid of 0 dot size. What we can do is I will be from very low and j will be from 0 because we are starting from this. I will be from n minus 1. J will be starting from left, so it would be from 0. So while I is valid and j is also valid, if this particular grid of I and j, we encounter the first j where this particular thing is negative. Okay, so basically we should add m minus this j, and we should skip that particular row. So we should also have our answer here, and in the other case we should just increment our j. I think this should work. What happened? Grid of I. Oh, it should be minus. Yeah. So what is the time complexity of this one? Basically, we are only moving from downwards to upwards, left to right. It's roughly the upper bound is big O of n plus m. Yeah. So finding this pattern is difficult. When we find this, then it's easy because we're going from just bottom to left. And every time we just don't need to reset j, because if we are finding j at this index, then next j should always be here or here, not behind this, because this particular pattern, because of this particular pattern. If the first negative is on this, the next should be always on the right or on the top of it. It should never come left side of it. So that's why we are never resetting j here. We only reset I to the above row. That should be the most optimal. Yeah, thanks.